I'm Brett Carver. I direct the Weed Improvement Program at Oklahoma State University, where I have been a researcher on the weed improvement team now for over 25 years. Wheat is a naturally self-pollinating plant, which means it can replicate itself. It's not the only plant like that, but it's very different from, say, corn, which is a cross-pollinating plant. So since wheat is self-pollinating, we have to make it become cross-pollinating so we can cross it. To do that, we have to first remove the male parts of the head, of the developing head, which means to remove the anthers, or scientifically we call that emasculation. And once we remove the anthers from one plant, we take the pollen or the anthers from another plant and physically place that pollen on now what is the female. This is a developing head. You see the kernels? There's 2 kernels right there. There's 1 right there, 2 right there, 1 right there. These kernels are the result of a cross, of a hybridization that occurred between this plant and another plant that I don't know unless I look at the tag and I take you to it. The wheat that we grow is really the result of a natural crossing event that occurred thousands of years ago between 3 grasses. Human civilization revolved around the evolution and domestication of that species of wheat. Our whole existence depended upon that plant thriving. And now, you think about it, now our existence today really depends upon the thriving of that plant, but now we're doing it, we're manipulating that plant in places like this instead of relying on nature to do it. Of course, nature, it takes thousands of years. Here, it takes us 10 years to go from a cross to a variety that farmers can actually use. Every year a farmer goes out and plants that crop, that farmer's taking a huge risk with the environment, the climate, pests. Wheat is subject to a lot of diseases, a lot of insect pressures. It's just a humongous risk. So as a researcher, I think it's our biggest responsibility is to minimize that risk, to produce the genetics that allows that farmer to succeed, because if that farmer doesn't succeed, we don't exist as a society. By producing the right genetics for the right environment, you know, the same genetics for Oklahoma may not work for Arkansas, may not work, certainly doesn't work for Washington because of the market class differences. But if we can combine the right genetics with the right management techniques, we feel like the farmer's going to have a better chance of success, and that harvest is going to happen.